All right, so the last thing we need to talk about before we start our Secrets and Safes project is how to use our microbits with Bluetooth technology. So uh, we're going to read through here and I'll kind of walk you through what it is that you need to do. As you explored during the digital dive in Activity 1.1, the brain, digital devices can communicate with each other through wired or wireless connections. In this activity, you'll practice creating programs and sending data wirelessly between two microcontrollers. To do this, your microbits will use Bluetooth wireless technology. According to legend, the 10th century Viking king Harald Blaatand peacefully united several Danish tribes to form one kingdom. His last name, Blaatand, translates in English to Bluetooth. In 1997, a new wireless technology was developed that connected many digital devices. The developer thought that King Harald Bluetooth would have been pleased to see mobile computers and cell phones united by simplifying how they communicate with each other. The new technology was named Bluetooth because it connected many digital devices, much like King Harald Bluetooth's uniting of the Danish tribes. Even the Bluetooth icon and logo you see on computers and smartphones today is a combination of King Harald Bluetooth's initials in the Old Norse alphabet, an ancient language. So yeah, you've probably seen that symbol before, maybe up in the corner on your phone, or maybe some sort of tablet or something like that. Today, Bluetooth wireless technology uses a standard radio signal to send packets of data from one digital device to another. The signal that Bluetooth technology uses is a 2.4 gigahertz shortwave radio frequency, so it doesn't travel long distances. This is perfect, though, when you want to listen to some music through headphones connected wirelessly to your nearby smartphone. So right up in here is the Bluetooth antenna. You can barely see it, especially in your microbit, because it's kind of a, black on black in a certain extent there. Whereas on here it kind of looks gray, but it's on there. Take a look at the back of your microbit microcontroller. Find the labeled BLE antenna. The Bluetooth low energy antenna may be difficult to see because it mostly consists of wires inside the microcontroller. BLE antennas use less power than standard Bluetooth antennas. These low energy antennas are great for microcontrollers because then you only need 2 AAA batteries to power the microbit. To activate the BLE antenna in your programs, you'll use code blocks from the radio drawer. So that's where you'll find the blocks to use the BLE antenna. What's the answer? As you may know, a math equation can include variables. Usually these variables are unknown values or numbers represented by letters of the alphabet. Let's take a closer look at the different types of variables used to store data in programs. I'm not going to show this video right now, so what I would do is go watch it on your PLTW notebook, or in your text, because the sound's going to be much better in there. So go watch that, and then you can pause this and come back whenever you're done. Variables in computer programs are used to store 3 data types, including numeric values, strings, or Boolean, such as states of true or false. In this activity, you'll use variables to store strings and numbers. One data type that a variable can store is a string, which is made up of sequences of characters like letters. In the following code example, the variable x equals a string of characters that spell the phrase "Hello World." What do you think str means in this example code? So it says x equals str "Hello World." Well, if you were to take this block and turn it over to the JavaScript, you would see that it would say x equals str "Hello World." So the following code blocks use a string to display text on the microbit's LED grid. So another way to use strings is to set a variable equal to the length of a string. You can also show the length of a string on the microbit LED grid using a length of string code block from the text drawer found under Advanced. What number do you think will be shown on the microbits LED grid when the following program runs? Okay, so it says to give it a try, create this program in the Microsoft MakeCode programming environment and run it on the emulator. So do that real quick. All right, now we're going to look at a calculation here. So we've already looked at strings. Now we're going to look at the numeric. Just take a look at the following math program where a variable is used to store a numerical value. Can you identify the math equation x equals 5 times 6 created in the code? So we've got on A button, set x to this math problem here, 5 times 6, send radio send value answer equals x. So on the other one, it says on radio received, name x. Well, we've established that x is 5 times 6. So when it says show number x, we should get the answer to our math problem. In this program, you can see two groups of code. These groups are event handlers. This means the first group of code triggers an event, and the second event handler executes the event or action. After the first event handler computes the value of x, the radio code block sends the value for variable x as the answer to another microbit. What do you think will appear on the LED grid of the receiving microbit when it gets the data packet from the sending microbit? Try it out. Okay, so build this code, hit the A button, and see what happens. Okay, after that, you're going to import this A23 math X file into the Microsoft MakeCode programming environment. You should know how to do that by now. The easiest way is just to click on it and then drag it onto the Microsoft MakeCode environment, and then you should get this problem right here. Okay, so this is the problem that they were just talking about. So it wants you to see what happens on here. So let's go back to the instructions and look. It says, to initialize or prepare the program, press the A button on the microbit emulator. A second microbit now appears in the emulator. Okay, so if I hit the A button, you will notice how it kind of lit up here, and then I got a second microbit showing up. Okay, then it says to run the program, press the A button on the microbit microcontroller. On the receiving microbit LED grid in the emulator, you'll see the value of x in the math equation. X equals 5 times 6 appear. So we've got our A, and then the number appeared on the other microbit. So if we actually had this set up and we had the same code on both microbits and one person hit A, it would send the answer to the other person. For the two microbits to communicate with each other, they must have the same program downloaded on their processor. This is similar to pairing two Bluetooth devices. Because they both run the same program, you can start the program from either microbit. In the emulator, try pressing the A button on the opposite microbit to send the value for X. So push the A button on the other one. I might have to there it goes. Okay, so we clicked it on here. Now if I hit A, it sends it to the other microbit. All right, code tracing a variable. Now we'll make the math program a little more difficult by adding more computations to the first event handler. Unlike variables in math, data stored by a variable in a computer program can change during the runtime of the program. One way to track how a variable's data changes throughout a program is to complete a code tracing chart and trace the variable. To develop the value of X when the following program is executed, create a code trace chart in your PLTW Gateway notebook. Okay, so you're going to make a chart that looks like this down at the bottom. All right, so here's our program. On button A pressed, set X to 5 times 6, set X to X plus 6, set X to X divided by 6, and then send the answer to the other microbit. So it says, for each code block of the program, write the value of X in the outcome column. Leave the correct column empty for now. To help you figure out the value of X at each step of the program, show your math work in the outcome column above the new value of X. So keep in mind, the value of X is changing here. So just to give you a hint here, I think we know that X originally here is 5 times 6. So whatever the answer is for that will now go into this X, because that was the previous value of X. And now we're going to take that value and add 6. And then we're going to have a new value for X that's going to go into here. So you're going to enter that stuff in this code tracing chart. When you have completed the code and outcome columns and know the final value of X, add the additional code blocks in the above program to your A23 Math Hex program. To run the program in the emulator, press the A button. Did you get the same value for X on your code trace chart as the number on the LED grid of the receiving microbit in the emulator? If not, see if you can figure out why by reviewing your code tracing chart. All right, smart devices. King Harold Bluetooth would probably be proud of how wireless technology has improved and connected more electronic devices over the years. Your smartphone can change the temperature inside your house or start your car. While you're watching a movie, your TV can display on its screen a text message notification from your smartphone. You can even activate a security alarm automatically when you leave your house. The term Internet of Things is used to describe the ever-growing network of connected physical devices. These electronic things, known as smart devices, communicate with each other using Wi-Fi, cellular, or Bluetooth technologies. Your microbits are smart devices because they can communicate with each other. As the Internet of Things expands, the security of those smart devices becomes important. Through security features, you can control how and what smart devices are connected to each other. To make sure only 2 microbits are communicating with each other, you'll use the code blocks in the radio drawer. You'll also make sure you download the same program to the 2 microbits to connect the devices. All right, remote control. So now you're going to start working with a partner. It says, working with a partner, create a new program in the Microsoft MakeCode programming environment that sends an input signal from one microbit to another microbit. The signal will trigger an output action on the other microbit. Okay, so you are going to work with a partner on this now. And it should be the person sitting next to you that the teacher has assigned to you. And from there, you're going to just read the instructions and do what it tells you to do. Make sure you're following the instructions carefully and try to get these to connect to each other. So good luck, and if you have any questions, let me know.